All right, so studying organic chemistry, what we'll notice is that carbon-carbon single bonds often form the backbone of organic compounds. However, they're not the only thing. In organic compounds, we can add what are known as functional groups. So these are just other types of bonds or other types of heteroatoms arranged in a specific way. And so we want to memorize all of these. There's quite a few, and this isn't even all of them, but these are the ones we're going to memorize. The first are just alkanes. Alkanes are just carbon-carbon single bonds. Right, so for example, you can have this molecule, or maybe one of these, right? Just carbon-carbon single bonds, and then of course hydrogens also. Next up, from alkanes, we can go alkenes. So you can see we went from this A to this E. This is a carbon-carbon double bond. For example, we can just have this, right? Two carbons just doubly bound to each other, and then some hydrogens as well, or we can add other stuff to it as well. Next up, we have alkynes. Right now we put this little Y in here. So this is a carbon-carbon triple bond. This is acetylene, the simplest alkyne, but we can have all kinds of other stuff added to here, right? Remember to draw these as sp hybridized, so they're 180 or linear shape. So there's the types of carbon-carbon bonds we can have, right? Single, double, or triple, and now we can decorate it with other heteroatoms. So we can have halogens. These are known as haloalkanes, or alkyl halides, either or. And so this has some kind of CX bond, and X is very often used as a halogen, right? So this X could be a fluorine, it could be a chlorine, it could be a bromine, or it could be an iodine, right? So just add these groups there, right? There's one right there. There's a chlorine. And then maybe we add a bromine here or something like that, right? So if you see one of these, it's a haloalkane. Next up, we have kind of oxygen type of things. A lot of these here. We can have an alcohol. An alcohol in general just refers to a COH bond, COH bond. And so we can have what's known as ethanol, right? We have this OH here. This is the alcohol that you drink. So this is the one that you're most familiar with, but anything with an OH is an alcohol, right? So this is an alcohol that's methanol. You can't drink that. You'll go blind if you drink that. And then here we have isopropanol, right? Used to clean your nails or electronics. So in an alcohol, we have a COH bond. Next up, we have an ether. Here we have a carbon-oxygen-carbon type of bond. So we could have something like this, right? Or, you know, vary the functional groups on here, right? You can put whatever you want, but you need carbon, oxygen, carbon. Next up, we have a thiol. A thiol is very similar to an alcohol, except it switches the oxygen for a sulfur. So we have a CSH bond. Something like that, or maybe something like that. Thiols often smell bad. So yeah, that's kind of cool little fun fact for you. And then we have what's known as a sulfide. And so this is similar to an ether, except now we have carbon, sulfur, carbon bond, right? So maybe something like this. And you can put all kinds of stuff on either end. It doesn't really matter. You just need that carbon, sulfur, carbon bond. Next up, we have amines. Amines are some kind of nitrogen-containing compound with all single bonds, right? So we have a nitrogen, and I'm just going to put R here. An R can be a carbon or a hydrogen, right? So the simplest amine is ammonia, and that's just NH3. But we can have other types of amines, right? We could have some just kind of carbon-carbon or carbon-nitrogen bonds on there as well. Don't forget that this does indeed have a lone pair. Next up, we have carbonyls. These have a carbon-oxygen double bond, and there are many types of carbonyls. First up, we have an aldehyde. An aldehyde, we have some kind of R group here. This can be carbon or hydrogen. We're doubly bonded to our CO bond, and then we have a hydrogen on one side, at least one side. It can be on both, or it can just be on one side. So for example, there's an aldehyde, there's another aldehyde, and then the simplest aldehyde you can have is with two hydrogens on both sides. That's formaldehyde. Next up, we can have a ketone. And in a ketone, again, we have this carbon-oxygen double bond, but now we have carbons on both sides, right? So we have R, except here, R can only be carbon. So we can have maybe something like this, right? All carbons, or maybe the simplest ketone we can have, this is acetone, also used to clean your nails or other things. Next up, we can have a carboxylic acid. A carboxylic acid, again, has some kind of functional group, carbon-oxygen double bond, but now we also have an OH here, right? So this is a carboxylic acid group. This is not an alcohol. They are two completely different things. And so you can put them, you know, your R group can be all kinds of different things. You can have something like this or something just like this. The simple one over here is acetic acid, right? So we've seen that in lab before. After that, we can have an ester where we just take this OH bond and make it an oxygen-carbon bond, right? So we have R, double bond O, CO, another bond to an oxygen, and then another R group. And both of these R's are here are carbons. So we have something like this, or maybe something like this, right? Or whatever you want to draw. Next up, we have an amide, which is similar to an ester or a carboxylic acid, except now we have nitrogens. So we have a carbon-oxygen double bond, and then we have nitrogens, right? And these R's can be carbons or hydrogens. So maybe something like this, very simple amide, or something more complex. And one thing to really remember about these amides is that they do have these lone pairs, and then these lone pairs are indeed in resonance with this CO group, right? So we can draw a resonance structure, something like this. And so what we can see in the both of these structures, right, in the real structure, this is indeed an sp2 hybridized nitrogen. So just something to be careful of with amides. Then next up, we can have acid halides. And this is like a carbonyl and an alkyl halide, right? So we have the CO double bond, and then we have this X group here, where X is a halogen, right? So chlorine, bromine, fluorine, or iodine. And then finally, we have what's known as an anhydride. And in this anhydride, we have a carbon-oxygen double bond, and then another oxygen, and then another carbon-oxygen double bond, right? So this whole thing here is the anhydride. And we'll see later on why it's called an anhydride. It's made by basically getting rid of a water and fusing two compounds together. And then not a carbonyl, but just something else that we'll see a lot more of later is aromatics. So the most common aromatic we'll see is benzene, which is just a 6-sided hexagon with alternating double bonds. And then we could put other kinds of, functional groups on there, maybe some alkyl chains or whatever. Later on, we'll see other types of aromatics that aren't these hexagons, but for now, we'll stick with these. So you just want to go ahead and memorize all of these functional groups.